Good day. Welcome to this episode of the X-Celerate webinar series hosted by ISQ and AVEVA partner in Southern Africa. My name is Jessica Pons, and in today's session, I will be introducing you to AVEVA Predictive Analytics, which is a no-code AI and machine learning solution that tightly integrates with the AVEVA Pi system for early warning detection, diagnosis, and remediation of equipment problems. And the technology has been successfully operationalized at scale by many leading industrial operators globally. But first, let's take a look at where predictive analytics fits into AVEVA's approach to asset performance management. The foundation is to provide an agnostic capability to access and manage all the information sources from current existing technologies on their plants, which is an input for digital twin, supported by powerful and proven APM applications across the asset lifecycle and operational value chain. First, it is to create the data infrastructure, which will then feed into the solutions, which will then give you data-driven outcomes. Firstly, setting the right asset strategy to optimize risk, cost, and performance towards a company target and manage regulatory compliance. Second is our large portfolio of analytical tools, providing you the right insight into asset health to match the asset criticality, critical impact on company targets. And third is our prescriptive capabilities to enable, which is enabled by the asset library, and which is a digital link between the knowledge shared and clients' best practices that can be leveraged by the connected worker through AVEVA's digital asset maintenance solutions for more sustainable operations. And at the end, we have in the complete picture, we have AVEVA Connect, which is the cloud portal which enables, which delivers a fast track that will boost our solutions in delivering on our customers' targets. Now let's look at the analysis part and what are the different solutions available within the AVEVA's solution stack. This technology has a strong return on investment, and customers see immediate and significant reduction in downtime and maintenance costs. AVEVA's Predictive Analytics uses historical data to model the normal behavior of your system and build a collection of operational profiles. The software uses these operational profiles to continuously compare the current values of your running system against the historical values. Organizations can then leverage this information to identify equipment issues and in their monitoring systems, which can help them to investigate the causes of any deviations from the expected values and to secure that the health and reliability of the assets. Some of the advanced configuration is in terms of training your data by cleaning and removing all the outliers, detailed alert thresholds on tags, using data playback functionality to test your models before deploying the models, templates for mass configuration and deployment, using the alert management and diagnostics functionality to manage the alerts for enterprise deployment, using the sensor contributions for troubleshooting alerts, using the full diagnostics with prescriptive actions, and we also have the case management and reporting. We can build a knowledge base with documented cases. Also reports on historical information as well. So the solution is a no AI and machine learning for assets and process anomaly detection and diagnosis as well. So you combine the diagnostics and prescriptive actions to accelerate troubleshooting, advanced alerts and case management for knowledge capture and reporting, data playback for testing and models, templates for fast and proven scale-up and configuration. So with deep and clear predictive analysis, so you've gotten the alert. So what's the next step to do? So first, you will investigate which sensors are contributing to the anomaly. With a trend functionality, you can easily deep dive into all the tags that are assigned to the model, and you can investigate which tag has most of the contributions. You can also use the full diagnostics, where you can look at the potential faults and related inspections with the prescriptive steps. You can also then, with the forecasting capability, forecast the urgency before a breakdown happens. Using predictive analytics for predictive and prescriptive analytics. So we look at some of the features available in the current version, and we'll also look at some of the potential features will be added in the future release of the software. So let's first focus on the main themes within the solution. We have model building, monitoring, analysis and diagnostics. We have administration, and also we have architecture and integration. So let's first focus on the model building. So I'll just highlight some of the features that's available, that's been enhanced in the current release. So looking at the model body, Viva is moving towards a hybrid or cloud deployment of the solution. We will have a single Analytic client. Currently, we have the desktop client and also the web client. So Viva is in the process of moving all the functionality that's available in the desktop client to the web client. Some of those functionalities has already appeared within the web client. So we'll have one single client. We will do the model building, the monitoring of your models. And this will also enable you to deploy your assets to a whole fleet. Next is to get some of the user-defined functions or properties. So these are properties you can use within the solution. So it's customizable. You can manage your user-defined properties, the types, and detail of those properties. You can use the drop-down menus, and you can customize those values. So customizations can appear on the Viva screen with the analytics features. So you have the alert management, case management, full diagnostics, assets, project for each screen as well. So Viva has some reserved and pre-existing properties which cannot be deleted, but you do have an option to create your own, depending on what you standardize as a company. So you can build a custom calculation or equation. In this field, the equation resolves when a user-defined property is selected, thus a new solution. So the inputs of your calculation field are one of four types of the elements. So the existing properties type in the same category. So mathematical functions, so you have the plus, minus, division, and also multiplication. So you have the left and right parentheses to define the order of your operations as well. You also have constants, numbers you can use. And each of these elements must have a space on both sides of it. So there are a few exceptions. The first element in a calculation has no space to its left. The last element in calculation must have no space at the right. So existing property tabs do not require spaces around them, but you can individually delete elements and relocate them with the calculation fields. Okay, that's the user-defined properties in terms of calculations you can define. So now let's go on to the monitoring. So in terms of the monitoring, we've added the sensoring tab. So to understand the sensor column, you can then look at the list view, and the sensor grid will appear. So it will provide you more information about your sensor. So these are all the tags that you've added in your model. So depending on which source you use for your tag values, you will see the information on your sensor list. So there's a few columns to look at. So we have alert age. So this is essentially how many days the longest uncleared alert has been opened. And then you have alert duration. So how many cumulative days the story endpoint has been in the alert. You can also look at the alert persistence, the alert's duration as well, divided by the alert age as a percentage. So you can easily manage and see which alerts and which states your sensors are in. So if they're flatlining, not that escalate, you can easily see that in the alerts tab, that's in the sensor tab. Next, we're looking at the trend, a quick trend. So some changes have been made to make it a bit more streamlined. So you can visualize the relevant trends in the clouds. You can look at your sensors, you can look at your model filters, you can look at your sensors or out of service, you can expand, collapse all the trends. And this also increases productivity. If you only want to focus on one trend, you can also do that as well. So after you've looked at your different trends, we're starting with looking at the OMR, which is the overall model residual. You can then do a deep dive into the individual tags. After you've looked at the trends, you can also adjust your alert results. So you click on configure point. This is where you can set your absolute deviation or your relative deviation. But remember, this is only temporary setting. So once you close your browser, those changes won't be saved because the alert results and deviations, those are defined within the model in the desktop client. So this is just for clients who want to do on-the-fly tuning to see, to change the sensitivity of the alerts. So this is the functionality that can be used for that. And the benefits of that is to increase productivity, and there's no need for you to do changes on a desktop client first, then you deploy to the deploy model. So it's a quick way for you to see how sensitive you want to make your model. Okay, next we're going on to the analysis and diagnostics, and we look at some of the few adjustments that were made. So if you're not using these functionalities as yet. So in terms of how this applies, so this only applies to projects or models that have been that's derived from a template, that's been created from a template. So these are applicable for template-based projects. So this create the screen summary shows you how the point metric-based project signatures contribute to the overall template or project-based for diagnostics. So you can analyze the fault diagnostics, which can help you identify the root cause of an anomaly, and much in the same way you would look at analyzing the medical symptoms. They can help you identify disease. So efficient fault diagnostics with detailed rundown into sensors, which gives you the fault diagnostic configuration and design coverage, fault diagnostic detailed view, customized and diagnostics with the user-defined properties. So those same user-defined properties that you define within the desktop client, you can then view them here as well. This also allows you to build a knowledge base on the anomaly resolutions as well with the case management. So this will give you an understanding of your asset operations risk with the forecasting. So you evaluate the time before an appealing failure, and this gives you a proactive decision making instead of reactive. And this is some of the benefits with predictive analytics at scale which you can deploy. So now let's look at the fault diagnostic view. So this looks at the historical diagnostics of your with a probability. So looking at the sensor contributions to the fault, so current, recent, and historical, so you can change the time range or the date range within the date selection. So this will give you current and historical. So you can also identify related past faults, and there's some benefits there as well. So this facilitated identification of possible faults and also continuous improvement with information for similar and previous faults as well that you can use. You also have the descriptive steps that you define within your TDT, which is a template design tool, which will then be visible within the fault diagnostic tool. You can also do case creation, then add those values in your cases, the currents. So let's continue. So we're looking at the analysis and diagnostics. So the fault user-defined properties. So within the desktop client, you can define a custom a fault diagnostic, a custom a fault based on the type, and you can categorize your fault and offer analysis assistance. So you can have the severity ranking, occurrence ranking, detection ranking, and fault condition to further explain what might be going on and to tie the project with the fault diagnostics. So you can also then to the case, you can also share the same fault conditions and potential failure modes and looking at the effect on the of the fault in the business. Now let's look at the forecasting and how it predicts the future values of a project point by extrapolating the current condition and of an anomaly and assuming a constant degradation. The forecast tab helps you to estimate the urgency of your response to anomaly by measuring the distance and estimating the time to reach a user-defined threshold. You can typically align the threshold with a known alert limit or a turbo point for a sensor that could force an outage of an equipment. So as with any prediction, you would use common sense and you would consult your experts, such as a reliability engineer, data scientist, or analyst, and you consider the cost and risk of premature equipment failure when making decisions based on the forecast analysis. So you can either select the linear or spline as an algorithm to determine the appearance of that line that predicts the future value. So the linear algorithm is better at smoothing out daily variations such as ambient temperatures, day and night cycles. It's slower to respond when degradation is not constant. And you can then choose the spline algorithm, which is better for being sensitive to change. So when degradation is not constant, this may display a large variation of errors, especially for sensors with noticeable daily variations. The solution also allows you to take a snapshot of the current trends that you are viewing, then add that information into a case. So it takes the whole context of what you want to showcase within your case. So you can click on the case, you can then import or insert the trend that you're working on. So if you're looking at your trends, depending on the start and end time you've selected, so all those values that you're looking at, that same picture can then be added to your case. And then when you're reviewing your case, everybody can have a clear view in terms of what you were looking at. And this, the benefit of this is gives you a complete documentation of the case, which also increases the productivity and consistency in your documenting your cases. So this eliminates the cut and paste or screen grabbing and copy and pasting images into your case. So this allows you to better manage that. You can also include and exclude sensors or tags from your trend as well, and that will be saved within your case. So now we're going to look at the Pi Asset Framework, RTS, and how that will enable you to do a mass deployment within. So if you already have created your asset structure or your asset model within AF, you can then use Pi AF to import that asset structure into different analytics. So the benefits of that is you can use PyF to abstract your Pi server and point naming when building projects. It's easy maintaining your Pi server without impacting the different models. And AF security it also applies. So it's secure, a transfer of your information, and this speeds up um, your model building as well. So now let's just look at how we would actually import values from PyAF as a RTS. Right. So there's two options. You can either import the values into a project, or you can use the matrix as well. So we'll start by creating a project from a template. Then we'll right click, we'll import the project points. We'll then click the add button, add hyperlink. We'll then say Pi Asset Framework. So once you have configured your RTS for Pi Asset Framework, you will then select the asset that you want to look at. You can already see you have your whole asset structure that's available. You can just select all the tags that you want to import. You can then click OK, and all those tags will be imported into your project. You will then have to map those tags to a matrix, which is a bit manual, but there's a quicker and better way to actually, more efficient way to do this. Instead, I'll show you now. So once you use the list, the user list, you can easily copy and paste. So using the user point list, you can easily copy and paste those values. So you click on add, you click on user point list. So with this, if you have already defined the metric name and the AF attributes, if you're already using the Pi builder, it's easier for you to get the correct attributes and mapping that to your matrix using Excel. So you can copy and paste matrix that aligns to the attribute. And you can just select the correct database or your RTS, and then your values will be imported into the project, which is quick and efficient. So now let's look at the architecture and the integration and the plan that AVEVA has with analytics. So like I said, AVEVA is moving towards a more flexible enterprise architecture. So currently on-premise, we have the model building that happens, alert management, point management, calculations, so all the functionality we currently have in the desktop client. So Viva is moving to a more cloud or SaaS deployment architecture of the solution. So this is where we'll have the historians, all your different data sources, which is on-premise, which we're able to connect to the Viva Connect portal, and then we will have all the different functionality available that we have on the desktop client available in the cloud with the Viva's predictive analytics. So this is what the Viva is moving towards, and we don't know yet which version they will have all this functionality available, but this is the move that Aviva is moving to. So this will then leverage all the infrastructure and the power of the cloud. So you don't have to worry about having a powerful server to run multiple deployments of your different solution. So then you will capitalize on the cloud performance. So all that you will have then is to have an HTML5 enabled browser and run as many tags or run as many models as per your license agreement. And then you can be able to capitalize on the power and resources available in the cloud. So that's all for my session today. So if you want to know more, you can book a session at our Customer Experience Center for more deep dive or detailed approach to all the solutions we have. And you can go to our website, www.is3.co.za for more information. Thank you for joining me.